Dear students, today we are going to discuss exercise 6.2 triangle chapter, fifth problem onwards. Given in this picture 6.20, DE parallel to OQ and DF parallel to R. Show that EF parallel to, that is EF, this line parallel to QR. So idea, just write the condition of the parallel, that is using a theorem, basic proportionality theorem, write this thing. For that, given first one, DE parallel to OQ. So by basic proportionality theorem, after that write the theorem statement. Here just write, please write the theorem statement in any one term, any one part. By basic proportionality theorem, that is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. This thing we need to write here. Don't write the theorem 6.1, theorem 6.2 like that. By basic proportionality theorem, that is theorem statement. If you are going to use converse part of basic proportionality theorem as theorem 6.2 as just the statement we need to write. So now consider the triangle PQO. Here given ED as a parallel line of OQ. So using this basic proportionality theorem, we can write PE divided by EQ equal to PD divided by DO. And the next one given DF parallel to OR. So that is in the triangle POR, DF is parallel line. The same way by basic proportionality theorem. That is, just write here your statement. After that, here by using basic proportionality theorem we can write. Right. PD divided by DO and PF divided by FR. So compare these two things. Now P D divided by DO, that is second one, it's equal to here first one. So automatically what happen? One side are equal means other sides definitely equal. So that is PE divided by EQ equal to PF divided by FR by from 1 and 2. So by converse part of basic proportionality theorem, we need to write the statement. If the statement write as it is, that is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So automatically by using this proportional ratio, that is ratio, we can write the triangle formed by this PE, that is divided by EQ, and PF divided by FR, PE EQ, PF FR, that is this triangle PQR. So automatically we can write in a triangle PQR, this line EF is parallel to QR. Okay, like that try to write. Okay, next problem. In a picture, A, B and C are the points of OP, OQ, OR respectively, such that AB parallel to PQ, AB parallel to PQ, AC parallel to PR. Show that BC parallel to QR, this thing. So here I am going to use the same basic proportionality theorem and the converse part of basic proportionality theorem. So first itself given in this triangle AB parallel to PQ. So consider OPQ, triangle OPQ. In triangle OPQ, by basic proportionality theorem means write the statement. Already I mentioned you that thing we need to write directly, but understanding, if the two lines are parallel, we can write the ratio. Converse what? If you have a ratio, we can write that two lines are parallel. So that statement we need to correct exactly because it's theorem. That is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Like that, right? That is, we can write the ratio in this triangle now, OA divided by PA or AP, OB divided by PQ or QB. Like that we can write. Next thing also given, AC parallel to PR. AC parallel to PR. Similarly, in a triangle OPR, OA divided by, that is OA divided by AP, OZ divided by CR. Compare these two things, OA divided by AP equal. So automatically these right sides are equal. So OB divided by BQ equal to OZ divided by CR. That is by converse part of this basic proportionality theorem. So that is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Here you need to write the statement. Statement we need to write. Write statement. So using this condition, I can write BC parallel to QR. So given now OB divided by BQ, OB divided by BQ, OC divided by CR, that is in the triangle OQR. So in a triangle OQR, BC parallel to QR. This thing we need to write. So all those things we need to write. I am not given all the steps here. Please, you need to write your steps. The steps are here. AB parallel. Here I am introduced. So while watching this video, you need to understand why I introduced it here. Everything not possible to write within a short period, so that I am not return the statement and all. But while writing a basic proportionality theorem, we need to write statement. Here converse part we need to write the statements. Okay. Next, using theorem 6.1, that is basic proportionality theorem. Here, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. So the given, prove that a line parallel to through the midpoint, one line drawn through the midpoint of one side of a triangle parallel to another. So parallel, one point, midpoint. So that is, in this triangle, assume that the triangle ABC, where D is the midpoint of the side AB and DE is a parallel of BC. So what do you want to prove? To prove that E is the midpoint of AC. E is the midpoint of AC. Now by basic proportionality theorem, write the statement. Theorem statement. Then only the proof is correct. So AD divided by DB equal to AE divided by EC. Now D is the midpoint, so automatically we can write AD equal to DB. So substitute here. So AD divided by AD, so you can cancel as 1. So AE equal to EC, that is AE equal to EC. That is AE equal to EC means ED is the midpoint of AC. So here idea, here used basic proportionality theorem, we return that parallel line. No, that is using this we can write the ratio, but this is the midpoint means this lengths are equal. AD we can cancel. By this we can write E is the midpoint of the side AC. Right. Similarly, using theorem 6.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So that is given two midpoints, any two sides of a triangle parallel. So we need to prove this thing is parallel. The same way, assume that the triangle ABC, where D and E is the midpoint of the sides AB and then AZ respectively, to prove DE parallel to BC. The previous problem we need to prove this point is the midpoint. So that here we need to prove the parallel condition. How can we prove this parallel condition? By using your theorems only. Now D is the midpoint, here E is the midpoint, no. So what thing we can write? AD equal to DB. Using this to form the ratio, that is AD divided by DB. We can write, we can divide DB on both sides, that is DB divided by DB. DB we can cancel as, that is AD divided by DB. Already you know that AD equal to DB means AD, we can write this one is left side as DB equal to 1. So AD divided by DB equal to 1. Similarly, E is the midpoint means AE divided by EC equal to AE equal to EC. That is AE divided by EC equal to 1. We can write here. So now one is here also ratio 1, here also ratio 1. One is 5 by 5, 20 by 20. That is these ratios are equal now. So like that, one side is equal. So A1, another one AD divided by DB, AE divided by EC are equal. That's why from 1 and 2 I can write these things are equal. After that, ratios are equal. If the ratios are equal means we can write the parallel condition, that is theorem 6.2 converse part of this thing. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. This thing. Okay. Next problem. ABCD is a trapezium in which AB parallel to DZ. On trapezium we need to construct, and we need to construct this thing, and is a diagonals intersect each other at O. Then show that. Now assume that ABCD is a trapezium. The diagonals means definitely AB is the adjacent vertices now. So AC is a diagonal. So diagonals AC and then we meet at O. So assume that this trapezium where diagonals meet at O and given AB parallel to DCY, it's a trapezium. The trapezium one sides are parallel. Now we need to prove this condition. Now just to construct a line EF which is passes through O and also which is parallel to AB and DC. That is parallel to AB and parallel to DC. Now consider AO divided by BO, like that we need to prove. AO divided by BO. Next CO divided by DO. AO no, so this thing we need to write. Suppose AO divided by CO, AO divided by CO. So what we want to write? Now consider the triangle ADC, this thing, because AO, that is AO and CO combined form. No, so consider this triangle. In this triangle AEODC. So in a triangle ADC, EO is parallel to DC. So I can use the basic proportionality theorem, write the theorem statement here. AE divided by ED equal to AO divided by OC. Next, similarly, consider DBA. First one, just this triangle. Second one, using this triangle. Got it? Only left side I am using. I am not using the right side. First one, this. This is the triangle. Second one, I want to use this triangle. Think about, then only we can write the common things. I am not used to any right side. Okay. Now, in the triangle ADB, think about, we return a reverse case. I have written a reverse case. Just write, I have written like that only. Okay. Written that means this is the triangle. So OD divided by OB, ED divided by EE. That thing. So that's why I am written like that. So EO parallel no DE divided by EA, OD divided by OB, or DO divided by OB. Right. Taking reciprocal on both sides. Why? Here AO divided by OC. No. But AE divided by ED. Here ED divided by AE. So that's why we need a reciprocal. So here AE divided by ED, here ED divided by E. So taking reciprocal on both sides, I can write AE divided by, then only we can compare. So AE divided by ED equal to OB divided by OD. From 1 and 2 we can compare. So left sides are equal, automatically right sides are equal. That is OA divided by OZ. I can write OA or AO. OA divided by OC equal to OB divided by OD. So now ratios are equal means by converse part of basic proportionality theorem. Please write the theorem statement. Here we need to prove as per given. So given we need to prove AO divided by BO. We got it AO divided by just OC, CO. Here OB. We can write the cross multiplication. Here we can write. So OA divided by here OB equal to OZ divided by OD, like that. We can exchange by using the cross multiplication. Otherwise you can write OA into OD equal to OB into OC. What things we need? OA divided by BO. So write here. Here OZ divided by OD. OB right side, this one left side. Like that, right. The problem may be asked here means stop it up to this. They are asked the answers like that. So we need to write this one also. Okay. Next problem, 10th. The diagonal of a quadrilateral ABCD, the quadrilateral given, intersect each other at the point O such that the same thing we need to prove. So that ABCD is a trapezium. So condition, quadrilateral given, the same O is given, but we need to show the trapezium. What is meant by trapezium? One sides are parallel. In the quadrilateral we have 4 sides, no? Then one sides are parallel. This thing we need to prove. So the same way construct the quadrilateral. That is in quadrilateral ABCD, diagonals diagonals AZ and then BD intersect O, and given AO divided by BO equal to CO divided by DO. This thing given. Now we need to prove that ABCD is a trapezium. Think about the previous case, we taken trapezium to prove this ratio, but here ratio given, we need to prove trapezium. So we can tell 10th problem is the converse part of 9th theorem. So if a trapezium implies its ratios are equal, if ratios are equal means trapezium. That is things is if and only if and only if. That means we need to consider first statement. We can tell the answers. If we have the answer, we can tell the statement. Okay, right. If and only if P implies Q means Q implies P. Okay, this is if and only if. That is P implies. This is the meaning. Study this thing also. We need to study in future. Right. For that we are consider this thing now. So just construct a line EF such that this EF is parallel to AB. Okay. Now we need to prove EF parallel to DC to prove. Then only if EF parallel to, we consider AB means, if EF parallel to DC means automatically AB and DC are parallel. So this thing already parallel, we constructed like that. We are going to prove this EF is parallel to DC, then AB and DC are parallel. That is trapezium, like that we can prove. So we need to show this thing. So for that we can show EO is parallel to CD also. If EO parallel means automatically EF. Right, given this thing also, AO divided by BO given already. As per norms, we need to write AO divided by CO equal to BO divided by DO. Already we returned this thing in previous problem. Then only we can in a triangle we can talk about a triangle. AO divided by CO. AO divided by CO. Now, previously given AO divided by OB. No, it's not a triangle from triangle same side. No. So thus change as per a triangle side. In that triangle, already you know that suppose A, B, C, D, E means AD divided by DB. We not thought about AD divided by AE. Already AB divided by DB. This thing we know that only AB divided by AE. Not possible to write. A, D, E. Okay, we can talk this side or this side. We can compare the ratio. Okay, like that change this one. Why we want to change this? This is the definition. So in that theorem we can use only the same sides only, not AD and then AE. Like that here change in the triangle. Right. After that we can tell the triangle. So that is AOOC. Next BO and then OD. Okay, that is a triangle ADB. Okay. Now basic proportionality theorem. This thing already we written, no? So next EF is parallel to AB means EO is parallel to AB. So in a triangle ADB, we can write already written AE divided by ED, BO divided by OD in a triangle. In this triangle we can use this thing, write the theorem statement. Now write this thing. Already this one is given. Now we are going to consider this triangle. In this triangle, this thing parallel means I can use basic proportionality theorem. So in this basic proportionality theorem, AE divided by ED or DE divided by EA, DO divided by OB, or AE divided by ED, BO divided by OD we written. Just to compare these two things, BO divided by DO, right sides are equal. So automatically AO divided by CO equal to AE divided by ED. We can write this thing. So in a triangle EO divides the triangle in the same ratio. So automatically we can write in this triangle only, no, from 1 to 2 AO divided by CO, right? AO divided by CO this side, and another one AE divided by ED, so that is ACD in a triangle ACD, in a triangle ACD, EO parallel to AB, also EO parallel to AB. Also now we proved EO is parallel to DC. In this triangle, this thing is parallel because AE divided by ED equal to AO divided by OC. In this triangle we proved already, it's given this line is parallel to AB. Now this line is parallel to CD. So automatically AB line is parallel to CD. So ABCD is a trapezium. Thank you.